4.4 Logic gates. What are logic gates? It's a circuit that has one or more input signals but only one output signal. This is an example of an integrated circuit with 4 logic gates. Each of them has 2 inputs here, terminal 5 and 6, and 1 output, terminal 4. So notice it can have one or more input signals but only one output signal. Each input and output can be either high logic 1 or low logic 0 voltages. So there's only 2 values, that is 1 or 0. 1 is for high voltage and 0 is for low voltage. It is used in electronic calculators, computers, and digital systems. Now let's look at the various types of logic gates. The first type is the AND gate. This is a simple example of an AND gate. And here is a truth table. A truth table is used to record all the possible combinations of inputs and their corresponding output for a logic gate. Here, when the switch is open, we put it as 0 and B also 0. So 0 and 0, and the output from the lamp is Y. So 0 and 0, both open switches. You should get also a 0. The next one is 0, 1. B is 1, it means this is closed. So 0, 1, this open, the circuit is still not complete. Therefore, the bulb here is not light up. So it is 0. Next, 1, 0. 1 means here it is switch on. When it's switch on, 1 is switch on but B is switch off. Therefore, the circuit is still not complete. And here it is still 0 because the bulb doesn't light up. Lastly, 1, 1 means that both is switched on. So since both is switched on, it is a complete circuit. Therefore, the bulb lights up and this is 1. This is the symbol for the AND gate. So this is the A input, B input, and the Y is the output. So this is the representation, the Boolean algebra A dot B, which is representing the AND gate. So it's something like multiply. So 0 multiplied by 0 is 0, 0 multiplied by 1 is 0, 1 multiplied by 0 is 0, and 1 multiplied by 1 is 1. So in summary, the output is 1 only when both A and B are 1. Notice when both A and B are 1, then the output is 1. Other than that, all are zeros. The next gate is the OR gate. This is an example of the OR gate. It has 2 switches that are connected in parallel. And here is the truth table. When both is 0, that is when both the switches are open, the bulb doesn't light up. This is the Y, so it is 0. When A is 0, open, and B is closed, that is 1. This 1, this 0. This is a complete circuit, therefore the bulb lights up, and this will be a 1. Similarly, if A is 1, B is 0, it also will light up because there's a complete path for the current to flow. And if both is switched on, 1, 1, also is 1. This is a symbol for the OR gate, A input, B input, and the Y, the output. For Boolean algebra, you can represent this with A plus B. So 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1. Note the difference, 1 and 1 is 1. Summary, output is 1 when either one of the inputs or both is 1. So 0 and 1 will be 1, and it's only 0 when both are zeros. Next, the NOT gate. This is a simple representation of the NOT gate. And here is the truth table. The switch is connected parallel to the light bulb. There's a resistor here. So when the switch is 0, that means it's switched off. The bulb lights up because of the complete circuit for the current to flow. So this becomes a 1. Next, when the input is 1, that means here is 1, it is switched on. When it is switched on, the current flows through the switch and no current flows through the light bulb. Therefore, it doesn't light up and it's a 0. This is a symbol for the NOT gate. It's a triangle here with a small circle. So here is A, the input, Y is the output, and using Boolean algebra, this can be represented as a line drawn above A. So that means not A. Summary, the output is opposite of the input. So 0 becomes 1,